Morning.
Morning.
Professor
Good
Shira.
morning.
Good morning, everyone. So hi, Levi. Are you ready? Thank you for being
Yeah, I'm
here
ready.
today. Okay, good.
Oh, it's
cool.
no problem.
Cool.
Yeah, I can start now. Let me clear this all out. Okay, so today I'll be covering, and I hope it shows up all right. Let me know if it's not. I'll be starting with the Bitbucket issue tracker. So I'm going to take this out here. Can you see the whole screen? Is anything covering it?
Yes.
This covering it here?
Yes, I think it's perfect.
Looks fine. Looks good.
Yeah.
Okay. Okay, so essentially today I'll be talking about how to integrate the Bitbucket issue tracker into our project and into the repository that we'll be using for Cyberwater. The objectives that we want to go over today, essentially, we want to learn how to navigate the settings and enable the issue tracking features. For one, learn how to navigate the issues category. I do want to mention, as far as I understand, we'll be doing this without Jira, although you can integrate the features from the Bitbucket issue tracker into Jira, but it's not necessary. It's not something we have to do. It's just if we were to have it, it would be another specialty that we'd be adding on to it, but not a requirement. We'll be learning how to create different types of issues. We'll get into that later. How to utilize and actually resolve the issues. One of the things I didn't include in the objectives, there are other options that we can use besides resolving the issues. We can also deny issues. We can hold them off or move them on to another participant that may be working on it. And we're going to learn how to interact with them through commits to the repository using Git or the version control management system, that whatever that is that we'll be using to interact with the repository remotely. So essentially, when you get to Bitbucket, one of the first things that you're going to see when you get to the repository that you'll be working with, this is my repository, my own test repository, but the Cyberwater repository doesn't look too much different, and what you're going to see and interact with isn't going to make much of a difference between mine and yours. So if we look over there to the side, we'll see the settings, and when you navigate to the Cyberwater repository, it'll be in about the same place. You may have some stuff on the left side added or removed, but ultimately I do believe settings is going to stay at the bottom. Should be easy to find. Moving from here, after we go into settings, we can find the issue tracker, which again should be somewhere around the bottom. It's one of the features that's been integrated into Bitbucket. It's very similar to the issue tracking system that GitHub has. Every repository management system like GitHub or Bitbucket tends to have some sort of issue tracking feature. Again, this can work with Jira, but on its own, it's really not that bad, and it's still very helpful. Enabling it, we want to make sure that for our Cyberwater repository that when we enable our issue tracker, that's going to be a private issue tracker, because currently we're working in a private repository. But later, I do believe we have discussed that, unless I'm incorrect, I think we've discussed making it public. After it's been worked on for a long time, at that point, we can make it into a public issue tracker. That way, external sources can suggest edits for us as developers to make to the Cyberwater repository when/if they are to find issues with the product. And they won't have any part in changing the code or anything. That's all on us. But they can find problems and help us solve those problems. Moving on from there, once we've enabled it, there should be a new setting that's appeared up to the side that should say issues. I'm going to go back. You can, from here, also from the, let me use this real quick. You can you see the red dot?
Yes.
Okay. There should also be an issue tracking area down here. I wouldn't suggest using it. It's not going to hurt if you do. It's just bad practice. It's good to use the tab over to the side. But here you should be able to create an issue in the top right corner. I've ran into people that have had a little bit of trouble finding it because it's white on white. But in the top right corner, you can create the issue there. And from that point, you can begin to detail what the issue is and how the issue occurred, what kind of issue it is, what its priority is. You can also specify the directory in which you found the problem, or if you don't know what the problem is, you can do such as leaving attachments or pictures of what you interacted with. Maybe there was a visual error that you encountered and you aren't really able to describe it programmatically, but you can describe it in relative detail to what's going on. This would be a really good place to do that. The more descriptive, the better. That leaves room for the developer to actually make changes that could make a difference in fixing the issue or bug or whatever it'd be. From here, it's pretty straightforward. You have it. You can assign somebody. That's not a requirement. None of these, well, some of these options are requirements. If we look over here, I don't know, it's kind of small, but there's asterisks on these two, which means that they are required areas that you have to fill out. It's either a bug enhancement proposal task, can't be blank, but you don't have to assign anybody to a task. Alternatively, you can choose to assign somebody else to a task. Say the person that was assigned wasn't really qualified to fix it, or they found that somebody else would be more qualified to fix it. Maybe they're better at back end and they want somebody to work on the front end that they know would be better at fixing that type of bug. That would be a good situation in which you would change the assignee. After that, I can't actually see what's at the bottom because I have something in my way, but it should have highlighted something where it says you can create the issue. And from there, you can select it and move it forward. And you should see now that it has been assigned to the issue tracker, and it's given its own issue number here. This is issue number 2. When I was doing this example, I had already done one before that, so this is the second one. And over here to the side, now that there is an issue here, you can choose to resolve it and explain how you resolved it, what you did to actually fix the issue in the issue tracker. That's not the only option that you're left with, but we'll get into that later. I would think that some of us have a general understanding, at least, of how Git works. Is there anyone in here that doesn't quite understand Git with version control? All right, I'll assume that most of us know that. So essentially with Git and all the commands that you can use when you're making commits to the repository, you can use this as a means of actually interacting with the Bitbucket issue tracker. It uses a regex and looks for keywords and phrases to identify resolutions or the counter to that in your messages when you commit to a repository, and I'll show that in a second. But yeah, resolving issues with Git, I would say, is pretty straightforward. Here at the top, I have my test repository that I have collaborating with Git and Bitbucket. And here I've just added an example file and used the git add command. And then when I committed to the repository and added all essential information like the author information and the message, I added some keywords here where I say, quote unquote, fixes issue number 1. I can't quite see what's at the bottom, but you all should be able to. I do believe it's what I had right here. But when I send out this message and it's committed to the repository, the Bitbucket issue tracker automatically recognizes those keywords and uses that to make edits to the metadata associated with that issue and marks it off as being completed or resolved, as they use in their terminology. So from there, we don't have to manually go back into Bitbucket on our account and say that we've fixed the issue. We essentially kill 2 birds with 1 stone, and it's essentially the end of it. There are a lot of phrases that you can use to actually resolve this. You could say closing, you could say fixing bug, fixes issue, resolving, and it looks for these words. I think that's all. There's one more. But synonyms to these, as long as you can remember one, that's all you need. But when you use these keywords and the number sign, the number of the issue that you are resolving, these are the keywords for that. The other things, the other actions, they call it, that you can do is you can reopen an issue. Say there's a situation in which you thought you fixed it, and then you go back to it later and you realize that it kind of fixed it, or you maybe did something wrong with the commit, or you made another commit that brought up the same issue. You can reopen the issue that somebody had posted on the Bitbucket issue tracker with the reopens or reopen keywords. You can also mark an issue as being on hold, and that's to say, I plan on fixing it, but at the time I have other priorities that I have to take care of before I can actually migrate to fixing your issue. And again, you would use very similar dictation where you have the keyword $, and then the number of the issue that you plan to fix. And then, whoops, there was only one for that. And then won't fix essentially says that you've acknowledged that they posted an issue. However, you don't have any plans in the near future or at all to work on the issue for whatever reason. Maybe it was just somebody's personal preference and they didn't like something in the way that the UI was designed, and you just personally don't care. It's not something that's on your list of priorities. You have better things to do. You would use the won't fix keyword in your commit message. One of the things that I would also like to suggest is that you don't have to, it's not required in your commit messages that you use any of these keywords or messages. It's just if you would like to resolve an issue or interact with an issue through your commit messages, this is how you would do it. And you can add more text than just this. You could say won't fix number 12, and then a description of why you won't fix it. This is just how you would if you choose to. You can also go to the Bitbucket's page and take care of that manually if you want to. You can also mark one of them as being invalid, just in case it were just outright wrong for whatever reason, or a link to a change set for the issue, where essentially you would reference it to something else. And I would say, as far as Bitbucket issue tracking, there's not too much more that comes with that. I would say it's pretty straightforward and simple. But if you guys wouldn't mind, I would like to manually go through and actually show how it would be used, just so I can make sure that there's not any confusion and how the Bitbucket issue tracker is set up and put together.
So thank you so much, Levi. That would be great if you do a demo of the very simple features of that issue tracker. And I think it's a great job. Thank you, Levi. Let me add one more comment. So first, I think Levi and I, we looked at Jira, and then we found out, well, that needs the subscription fee for every year. Yeah, so with Bitbucket's own issue tracker, it's totally free, but it provides us with the bare minimum features that we would need to be used in this project. Okay.
So for the sake of this, I'm not going to entirely turn mine off, but essentially in the same area. They seem to have renamed it. Here it says repository settings. Before, when I had taken the screenshots, it just said settings, but
yeah, that's okay. Yeah,
it's the same. It's the same thing. And then down here in the under issues, issue tracker, you can update it to say a private issue tracker, or if I wanted this public, I could say public issue tracker. And upon enabling this, we'll get this area right over here where we can begin to make an issue. So first off, let's say I want to do something with the repository real quick. See. See into repos, test repository. Say I make a nano example2.py. Real quickly, env3. I have it set up for Python 3, but if you all know anything about Python, I'm going to go ahead and make a syntactical error for Python 3 real quick, where I'm going to say print hello world, and I don't have any parentheses around my commit file example2.py, and then I'm going to add this. So after making it, first, if we were to look at status, notice I've not added this file yet, so I'm going to go ahead and add it right now. Git add a status. Everything's good, and now it's just asking that I make a commit. So I'm going to go ahead and say git commit -m. Example2.py to the repo. Let's say --author is equal to my username and Levi Connelly at bsu.edu. Hopefully I'm not making any typos. And because I recognize that I'm doing it from the Raspberry Pi Emit Global. So I'm going to go ahead and set up these real quick. XE. Realized that I was using this for TechPoint. That's my bad. So I had something else set up for this. I'm gonna have to change that later. I was using this for my other work. Here we are. So now I think should be able, maybe, there we go. So now we're fine. So now if we look at source code here, after I push it, push. Now we should see an example 2 in there. Awesome. So we're going to go ahead and make an issue real quick, create an issue. Syntactical error in example 2. I don't think example 2 meets Python 3 specifications for syntax, and it won't run, or at least I think it won't run. It won't. And I'm going to go ahead and assign this to myself. Kind of bug. It's a bug. I'm going to go ahead and say that it's minor, and I'm not going to attach any files. I think there we are. Have to drag some stuff out of the way. I have more windows on my screen than you guys can see because of how I have Zoom set up, but every time I have to move everything out of the way when I press buttons. So now we should have issue 3 up here set up by the repository owner, which is me. And I could, if I wanted to, I could resolve this from here by clicking on this and hitting resolve and explaining why, how I've resolved the issue, which actually I haven't. So let me actually go and resolve the issue first, because that's step 1, right? So let's add parentheses to this such that it would run. Also, if we were to have Jenkins set up for this, we were monitoring this file, looking for certain outputs. I do believe that would be Jenkins throwing an error at us and saying that it didn't like what it saw either, because I think it recognizes syntax errors as well, any type of error, as long as it's monitoring it. So now git add -a status, git commit -m, and we're going to say fixes issue number 3, and we're going to say the author of the repository is going to be, I could use LT Connelly for this, but I can't quite remember, so I'm going to go with LT Connelly this time. You'll just see minor differences in the naming conventions at the front, as long as the email is the same. I don't think there should be any issues. And then I'll say git push, and it should push this to the repository after it asks me for my password yet again. And now, if we go ahead and reload this, we should see that it's resolved, as it is right up here. And it says fixes issue number 3, which, if we notice, was the exact same commit message that I'd put in here. If I'd added a random string of letters or sentences after that, it would have also been included right around here. So it's, if I wanted to reopen it as well, say touch something.txt and echo some stuff into something. Sure, there's something in that. There is. Status. You need to add that. A git commit -m, and we want to say reopen number 3 for no reason whatsoever. The author is going to be me. Push. My password again is getting a little annoying. There we go. I do believe now it should be reopened, and it is. Notice I reopened it here, and it says for no reason whatsoever, which was what the phrase that I'd put in here earlier. So that did carry on, and just because I added some text to the end, it didn't throw off the issue tracker and recognizing it, because it's a fairly simple regex it uses. It's kind of like if you were using grep to just look for keywords and then a hashtag and a number. So it's not too hard for it to find it and see that you wanted to do a thing with the commit. As long as you have issues enabled in the repository, it's pretty straightforward in finding it. And if I want to resolve it here, I could do that as well. And then here it's resolved again. So I would say as far as issue tracker is concerned, that's about as much for that as needed. There are also ways, as far as like the workflow, new, open, on hold, duplicate, invalid, won't fix, closed. It's kind of like what we were seeing in some of the last slides that I'd went over when I was talking about these other actions, marking it as invalid, marking as this, that, or the other. You can also choose to delete them, mark them spam, attach files to them, or you could even edit them if you are the person that made the thing in the first place. Say you made a mistake, you can go back and change it. So I would say this is pretty straightforward. If there was any small things that I forgot to mention, it wouldn't be too hard to figure them out. You can watch certain issues. This is actually, glad I recognize this. This is an important one. Typically, if you make the issue in the first place, you're automatically going to be watching it. But say you were an external person who did not make the issue, recognized it, saw it on the repository, and you also wanted to know when it was fixed, you would see this right here, which would say, watch this issue. And you just click it, and then when the issue is resolved or when some sort of action is made with it, maybe it's not resolved, maybe they're saying they won't fix it, you will be notified. It will tell you, it will let you know whatever happens with it, so you can stay up to date even if you are not the one that made the issue in the first place. But if you are, this will automatically be enabled, so you don't have to worry about it. Do we have any questions regarding this?
Yeah, I do have one question. Yeah, thanks for this example. It's very helpful. I didn't know like I can embed those command in my commit message. So is that only Bitbucket aware of the command in your commit message, or is like it's a very general technique? People also use it in other like GitHub or GitLab.
I think GitHub also has it. From what I understand, I think, yeah, they have it. I know they have it because I did the same thing. Yeah.
Yeah, should be a feature of GitHub, basic feature of Git. Yeah.
Okay.
I used it with my previous project group that I was working with back when I was in CS222.
Yeah, that's
and I remember them having it then. Yeah.
Yeah, that's very convenient.
Yeah, it was really useful when we had to get a lot of stuff done fast, for sure.
Yeah, thanks.
Can you click zero issues? What's there here?
What was that?
Can you click this zero issues?
Jira issues.
Yeah.
Yeah. This was something new that they implemented like very recently, so I don't unfortunately know anything about it.
Okay.
From what I understand, it's saying something about a free trial. So I would imagine that this is just their business strategy to get people using the platform. And then when they start using it and they realize they like it, then they're like, hey, you got to pay for this now.
So Jira issues, I think those were the things we started with, and then we found out we need to pay for that. Yeah, that's why
Jira issues, it's essentially, it's the issue tracker that we're using now, but it is extended into an environment that I would say is more user friendly. I would say it's more straightforward, it's easier to organize, and it's more expensive. Issue tracker that we have, the free one here, this doesn't cost us anything. We can use it as many times as we want, and they're not going to yell at us to pay them. But with the Jira issues, we have a 7-day free trial. And then after that, it's whatever price, you know, with academic pricing or with standard pricing, whatever they ask for is going to be associated with whatever comes after this 7-day free trial. So it's nice. I'm not going to, you know, throw it off and say that Jira's bad. It's not. It's actually, it's pretty wonderful, but it is a little expensive. I wouldn't go for it unless we were like a large company. If we had a lot more people, I could see it being more feasible, but for as many people as we have, the issue tracker is perfectly fine. We can easily manage everything in the issue tracker without having an interface like Jira. The worst case scenario, we just use Trello, and I think that solves a lot of the issues that we would be using with Jira anyway. You can also, if you choose to, I do believe you can take these issues and you can integrate them with webhooks. I think I can actually check that right now. And that would, honestly, I would personally say that's not too much different from, I'll let my brain think for a second. That's not too much different from what Jira does. I know you can do it in GitHub. I don't actually know yet if you can do it with Bitbucket, but I can look into that another time. But yeah, that's the Bitbucket issue tracker. It's pretty straightforward. I enjoy using it. I think it's just the way that it works with Git commands. I think it's pretty cathartic to be able to fix it that way. I think it's way easier. It's just really simple to knock a lot of stuff off in a few commands. Another thing is if you have an IDE, you can have most of the work with what I do with the terminal, with adding and committing. You can usually have that done with like 1 or 2 commands in an IDE as opposed to like the 5, 6, or 7 that I do in the terminal. But I just personally like doing it in the terminal because then I know everything that I'm doing. Whereas with the IDE, I don't know, I don't trust it. I know I have trust issues with when I don't know exactly what's going on behind the scenes. So I like using the terminal.
Okay.
So what is the difference between GitHub and Bitbucket? I mean,
I'd say the difference between GitHub and Bitbucket as to why we're using Bitbucket instead of GitHub is the way that Bitbucket has managed the private repositories and how we are able to essentially utilize their quote unquote academic pricings and offers to have more participants and collaborators in our repository for free. And I like free. Free is good. But yeah, just it was a good deal for not having to pay for stuff, but still have a set amount of collaborators for a private repository.
Exactly.
And we were pushing for a private repository. Well, you could have as many as you want on a public repository, but this is something we want any people looking at yet. So Bitbucket was, when we were looking at it, and still right now, was the best bet for that. Now, there was an issue that I've been seeing lately that may or may not get resolved in the near future after we talk to some people, where we were looking at the allocated size that they had given us for the repository, and from what Dr. Leonard said, it doesn't seem to be correct. I'm more than happy to talk to somebody on the phone or email someone and get everything worked out with that. But I would say overall, and not that GitHub's bad. I prefer GitHub personally, just because every other repository I use is there. But for academics, in our very specific scenario, Bitbucket was a better choice.
I think Levi looked into this earlier, and because the major reason is because we want this to be a private repos. Yeah, so I might not get it wrong when I might have got it wrong when I said, well, the size size that they allocated was not right. Because later I did it a little bit more on the website. It's probably the size that they gave you, very small, like the hard disk size. Yeah, so it might be that. So we have to think about another way, because this is just too small.
Okay. In the worst case scenario, if we want to use GitHub again, I remember earlier in last year looking into how we could migrate this repository over to GitHub, and it's not that hard.
Okay,
we
great.
could do it. We could do it in like a day. So it's, if we decided the last second, hey, we shouldn't have used Bitbucket, let's move everything to GitHub, we could do it. No, it wouldn't be a problem.
Okay.
So.
Great, Levi. Thank you. So are there any questions on the Bitbucket issue tracker? More questions on this?
If there is another one called GitLab, right? I mean, how does that compare?
GitLab? I can't tell you for sure because I've not looked at GitLab, but I've heard of it a few times. GitLab, web-based DevOps lifecycle tool that provides a Git repository manager.
Okay, I mean, if you haven't looked at it, that's okay. I mean, we can, because in some projects we use GitLab, some projects we use GitHub,
Yeah, I can look at it after we get off call.
Yeah. Okay, so
one suggestion, sorry to interrupt this.
Go ahead.
It's great, Levi, and thanks for that. So after this, and if you get a chance to look at that, could you look at that like GitLab, GitHub, and this Bitbucket, and do a quick in summary in terms of their differences, so that we get a better sense, like what are the differences among them. Just a very brief points type of summary. Is that something feasible?
Okay, yeah, I can do that. I would say the only thing that I've really not looked at was GitLabs. So I could talk about the differences between GitHub and Bitbucket, and I can get back to you on GitLabs.
Yeah, but yeah, there is no rush, and when you get a chance to look at the GitLab, and you can, after you get some feeling about that, and then you can write a brief summary about their differences, so that we have one thing, all of them in one place. It's easier for us to keep track.
Yeah. Well, from what I understand already, because I've had a lot of experience with GitHub, because I edited a lot of other people's repositories, open sourced repositories, and I just collaborate with random people on random projects, mostly stuff related to OSINT investigation and such. But one of the things that I found is, honestly, GitHub and Bitbucket, they're not that different at all. I would say probably the biggest difference is that Bitbucket is much more targeted towards marketing, and they're a lot more straightforward about it, where they want you to buy things and they want you to look at their products and they're like, hey, look at what we have, you should spend money on our stuff. Whereas GitHub, I would say, is more community based. It was built off of a community. The community built it from the ground up. They do have, things that they sell, and I don't want to say that GitHub doesn't market, because they do. But they are less blunt about it,
Yeah,
they're like under the covers, like, I want you to
know
my stuff.
Yeah, that's good to know.
Yeah.
One quick question, which is actually irrelevant to this, it's just my curiosity, and to get some thoughts or feedback from you guys. The question is, we're like open source and things are free, but then there is an issue there that it's open source and it's committed to actually really maintain it. And so maybe years down the road that open source is no longer maintained, and there are issues with that. So my question is, how do you guys feel about this challenge versus going with a commercial one, which has better maintenance down the road in general, but then you have to pay the price. And so I just want to get some sense from the young people here. We know that each case has its own pros and cons, but then how do you guys deal with that kind of issues? Because you need to decide, right? And for whatever you're doing, and if there are different choices, open source versus the commercial ones, why do you decide to do the open source rather than the commercial ones? Levi, could you go first?
Okay, well, the reason that I decide that I like going with open source as opposed to commercial use, from what I've understand and through my experiences, I've found that with open source, at least in today's age, from now, I've not had a lot of, I don't know much about the history behind how open source software has been in the past, but currently, especially with GitHub specifically and large open sourced areas for maintaining code and leaving it there to sit and rot or whatever you want to do with it. I would say it's pretty well maintained on places like GitHub, and being maintained, it can be maintained for a very long time. There are conditions, of course. Mostly the conditions are it's easier to maintain a lot of stuff when it's public. They do like your stuff to be public because they want you interacting with the community. They want you to, you know, be involved. But if you're just trying to keep stuff to yourself, they want to profit off of that a little bit if they can. If you're doing a lot of work and you're taking up a lot of their storage space, but if you're contributing to the community and such, then they are more than happy to host your things and help you out, and at the expense of, you know, you being targeted a little bit with advertisements. It's fair trade. So.
Okay, thanks.
Yeah, so sorry for interrupting. I just Googled GitLab, and it looks like it says start a free trial. There's a free 30-day trial. Well, so I'm not sure whether that is totally open source. That is totally free. That could be one consideration. So I think we looked into the difference between GitHub and Bitbucket, and I think the major, if I remember that correct, the major reason why we chose Bitbucket is because we want like unlimited number of collaborators for the private repos.
I think that's a good point, and it's really the good thing that we want to do that way. We don't want to be limited. I remember you guys send out the emails. The GitHub has some limitations in terms of how many people can join for free, right? Because we all want to open source kind of stuff for free. Yeah, sounds great. Thanks. Sorry for the interruption. Please go ahead.
Oh, you're good. I enjoyed the interruption.
Okay. Thank you very much, Levi, on this presentation. I know that you have more to present today, but as I know that Isuru will have another meeting later today. So I would suggest maybe next we may allow the Isuru to present first, and then after he finished, and then Levi, you can continue your other topic. How about that?
I can do that.
Okay, thanks very much.
Okay, thank you. Levi, until what time can you stay? I'm just afraid whether he needs to work.
I can stay until probably around 2:30. At 3, I have a meeting.
Then never mind. Okay, no
that
problem.
will be good enough.
Okay, thank you. Thank you. Great job, Levi. Thank you.
Thank you.
Thank you. Okay, shall I share my screen?
Yes, please.
Yes.
Okay, hello everyone. So I'm Isuru Ranawaka from Cyber Structure Integration Research Center. So today I would like to present about the software architecture, some highlights of software architecture and how it has been evolved so far, and some software development best practices and software development automation, software testing strategies that we are carrying out in our team. So first of all, when it comes to software architecture, in early stages, we have seen that software is developed as a monolithic three-tier architecture, where the software itself contains the presentation layer, application layer, and data access layer. So all these layers are tightly coupled, and uh, and those are distributed as a single software. So when it comes to presentation layer, like we can see that this is the place where humans interact with the software, and it contains all the UI components and how data is represented, the data views, and it contains endpoints for the humans to interact with the software. And the next layer is the application layer, where actually the main logic of the software is executing. So this layer, this application layer, is in early stages, it is tightly coupled with presentation layer and data access layer. So so this application layer itself contains data models and transports, that kind of things, and specific logics that it requires to develop the use cases. In data access layer, it is basically the data fetching and data storing to databases, uh, that kind of stuff. So application layer talks to databases through data drivers, probably. So these data drivers are specific to each technology that we are using to store the data. So if we are using with MySQL, we have a MySQL database driver. If it is MongoDB, then it has a separate database driver for that. So anyhow, like with this monolithic three-tier architecture, we cannot, it is not reusable, because if we want to develop another software with some specific functions of uh, already existing software, we cannot reuse with this architecture. So with the help of distributed computing and with the evolvement of this software service-oriented architecture, so these layers are decoupled into separate services. Like front end itself is a separate software, application itself is another software, and data is another software. So front end, so earlier the front end presentation layer is not isolated, it is not run separately, it doesn't have that capability. So, but the front-end services, when it comes to service-oriented architecture, the front-end services basically it can run in an isolated environment, and it has its specific attributes, specific functions, specific roles for that. So for example, let's consider this Cyberwater project. So here we have the gateway portal. So the gateway portal itself a front end service. So so that web pages, there are static web pages, dynamic web pages, and data passing logic. So all these software functions running in a separate web server that is act as a front-end web server. So next thing is the application layer that we called earlier. So it is converted into application services. So it contains the business logic actually. And the database related functions are grouped into a database services. So this application service call the database services through network calls. The front-end service also talks to the application services through network. So in earlier scenario, it is not going through the network. It is a interaction between processes within a single JVM, within a single VM. But here it is talking to these distributed virtual machines through network functions. So in the latest approaches, the application services is further decoupled into separate services called middleware. So the software developers and architects found that these application services can be further generalized into middleware as a middleware services where we can support multiple applications. We can bring the multi-tenancy here. Basically, multi-tenancy means we have there are some common functions and we can group that functions together and package it as a middleware service, and any business dependent services can call to this middleware service to get their work done. So the software, so the end developers, so the business logic developers, their work is getting simplified with this approach. So for example, in Cyberwater project, we know that we are using the Apache Iravath. So Iravath is a middleware service, and so Cyberwater related logics use cases are developed independently, and those services talk to Apache Iravath to get their work done. So this concept actually simplifies the end developer's work, and so this middleware, when it comes to middleware, so the main functions that middleware is handling is the API management. So API management is basically so the middleware uh, should have some API contract between their clients. These are the APIs that we are supporting. These are the functions that we are supporting. And so the end client should be able to connect to those APIs through through various technologies. Like these APIs can be REST endpoints. These APIs can be some kind of remote procedure call, that kind of things. So comes into the API management and how to version these APIs. Like so previously we supported this API. Now it is getting evolved and new attributes added to the API. So we should have some API versioning mechanism to differentiate those services. So this API management is a critical feature, and it is a very complex. That's why it is moved to the middleware layer. So it is further eases the end users, end developers like business logic developers work. And middleware is responsible for messaging. Basically we can identify two types of messaging. like synchronous messaging and asynchronous messaging. So the in synchronous messaging, what will happen is like the client request particular client talks to a particular API, and client waits until the result is returned, right? So in asynchronous communication, client does not wait until the result is appeared. It do its own work, and the backend system, right, this middleware should interrupt that client when he is done with his work. So so both synchronous and asynchronous messaging are integrated into middleware. So we can see that we can say that HTTP 1.0 is synchronous messaging style, where it has a request response messaging style. So in asynchronous messaging, like we are using some libraries like RabbitMQ, uh, Kafka. So the basic patterns are like publish subscriber protocols, where the clients publish to a topic, and subscribers of the of that topic get notified through it. Uh, so these are mm, and there are some, yeah, the basic asynchronous messaging is works in that way. The next thing is the authentication and authorization. So middleware is responsible for user authentication, user authorization, and identity and access management aspects of the software. Moreover, like we can see the message transformations, because there can be some services, some backend services. So for example, let's assume that clients uses particular XML type message, but backend accepts only the JSON type messages. So that XML to JSON conversion happens through this middleware. So that kind of transformations need to be done through middleware. And the next is a service orchestration. Service orchestration simply means like, let's assume since these are distributed services, this middleware should talk to different backend databases or different backend services. So in case like let's assume that in Cyberwater project we have Apache Irawata, and behind that there are high performance clusters. So let's consider a use case where we need to orchestrate between these high performance clusters to get particular work done. Then this Apache Irawata should be able to communicate these numerous HPC systems and get the work done. So that happens seamlessly to the end user. So now what happens is this middleware itself is becoming more complex. As we see, all these functions are getting bind into one particular software, and this software itself is a very heavy one. So this heavy, so that the problems comes when it's going to deployment, right? So in early stages we have hardware, and now we have VM, virtual machine clusters. So deploy this middleware into VM clusters, hardware, we can do that, but the scalability of this deployment is a problem, because right, we cannot, it takes some effort, it takes some extra effort to scale the middleware through VM clusters, because it has a lot of software functions bind it together. But now we have seen that deployment technologies is rapidly evolving, right? So now it is, earlier it was hardware, then it comes to virtual machines. Now it is came to the container world, and the future will be the serverless models. So migrating from virtual machines to containers actually requires the uh, modification in the software layer as well, because we cannot deploy this heavy middleware into the containers. The container concept comes with a very small startup times and small functionality. With so the lot of containers together itself provide a particular business use case. In order to satisfy a particular use case, the lot of containers needs to be talks to each other to get that work done. So deploying this middleware itself onto a container is not is not the best practice, because it violates these memory requirements of the containers and the startup time, bootstrapping times of containers. So those need to be very minimal. So in future, what happens is like these containers will move to serverless architecture. The serverless architecture is basically like we deploy the functions to cloud cloud services. So the software function will be a service, and it will be managed independently. On, like, we know that already there are AWS, Azure, and kind of cloud providers. So these software functions, they allow to deploy these Lambda functions into into their services. So, and now we can see that industry is adapting to agile development. So agile development is basically, the team is a very small team, and they are working on some particular use case, some particular use case, and this software, this service is changing very rapidly based on the feedbacks provided by the clients of that software. So it requires a frequent independent releases, and frequent deployments of that software, new version deployments, that kind of thing. So in that kind of scenario, the maintaining this huge middleware is a problem actually. So what happens is, so now, so the current trend is like to divide this middleware into specific microservices. The concept of microservices came because of these container-based deployments, these agile developments, and a small number of developers per team, and independent release management cycles. Due to these reasons, this microservices concept is introduced. So this middleware, we need to, we have seen that this middleware contains like identity and access management software functions, API management software functions, like data management software functions, message transformations. So now what happens is these different functions are divided and independently deployed into different containers. So migrating this, or like moving this middleware into microservices based deployments is itself has some issues. It is not straightforward, but we need to do it in near future. So the middleware, the era of middleware will be vanished pretty soon. So when it comes to the microservices concepts, when we're developing a microservice, we first need to identify the coherency between these APIs, and highly cohesive set of functions are coupled together, and those APIs, small number of APIs need to be developed for a particular microservice, and there should be a well-defined API contract for that microservice. So when it comes to microservice, so there are two ways of handling the database for these microservices. Basically, shared databases or per service database. Like for each microservice, there is a particular database for that microservice. But the problem is if we go with the shared ones, we don't need to consider about database inconsistencies, because we can implement database because databases are synchronized in shared case, but when it comes to per service level database models, the database inconsistency is a problem. In that case, the concept of eventual consistency comes to plays a vital role there. So there are different patterns to manage these inconsistencies in microservices. The next thing is, since we are deploying these services in containers, so the container management itself will be a problem. For that, there are some platforms like Kubernetes and Docker Swarm, like where we can deploy these containers and manage these containers. So the container management itself is a huge task in that case. So with this microservices concepts, the earlier mentioned issues will be addressed, and once we get the pitch correctly, so the software development, maintenance, and release cycles will be very easy with the microservices concept. So any questions on this section?
Continue, Isuru.
Okay, so slide. So next, in next section, I'm going to introduce some software development best practices. Like, so when we're designing a software, the key factors to consider is, first we need to identify who are the consumers of that software. So like, what are their use cases? And then we need to analyze, we need to draw some flowcharts, we need to draw the use case diagrams, and we need to identify the key factors, key determinants, such as how many concurrent users are there, and how many clients will be, what type of clients is there, are they web clients, are they desktop clients, are they mobile clients? So based on these types of clients, based on the concurrency, the design aspect will be different. And we need to decide the technologies. What is the technology that we are going to use to develop the software? Like, so for example, let's assume that we have a lot of IO requests, but not computational intensive tasks. Then we can select the Node.js libraries for develop the software, because the Node.js is very capable of handling IO requests, but the thread model inside the Node.js is not capable of, is not very well designed to deal with computational intensive tasks. if there is a mix of computational intensive and IO related operations, then we can go with the Go language. Likewise, for the let's assume for web development, like for the front end services development, we have React. We can use React.js, or we can use Django framework, or we can use Angular framework. So that kind of, so we need to decide which technology we can use. So these technologies has specific attributes, and then we need to decide correctly what technology we can use. And next, we need to think of the API layer. What kind of APIs? So we can use like REST APIs, whether it is RPC. If it's come to RPC, we need to think about the forward and backward compatibility of these APIs, because when we change our backend services, how will it affect the existing clients? That kind of things need to be think when we designing the API layer.
Isuru?
Yes.
Can you just very briefly explain what is REST and what is RPC?
Yeah, so the REST is basically representational state transfer. That's basically it is technology to exchange the data between clients and APIs. So it is based on verbs, nouns. It is a terminology basically. These REST URLs are formed based on noun, verb concept, and resource concept. So REST assumes that all the APIs are resources, and you can do some operations on top of that resources. Like for example, let's assume we have an API to create experiment data model in the Airavata. So that API, create experiment API, is a resource, and in the REST URL we have post method. So post is a verb, so it posting some data to that resource. So it will create experiment resource in the server, and the noun is like a post, and we have URL, it represents the noun. So this web, so that is the terminology of REST in briefly. Like in RPC, remote procedure calls, what happens is it is communicating to the client, and server communication happens through the stubs. So there's a concept like stubs. So for example, we have thrift stubs, like we can develop the thrift, some proto definition, and based on, so there are API definition languages for RPC, and we can define message modules, services there, and we can automatically generate stubs. So these stubs are capable of communicating through distributed networks. So clients can connect to these services through stubs via IP and port and method identifiers. So that is the basic difference. I think it will help. I think it help you. So next thing is to decide the database technologies. What type of databases that we need to use. For example, let's assume there are a lot of correlations in between the data that you're storing. Then we can better to choose MySQL database. If there are like a lot of JSON messages kind of things, and heavy JSON messages are transferring in between, then we can use the MongoDB like database, NoSQL databases. Next thing is the transport layer design. So when it comes to transport layer design, we need to, the key factor to consider here is how many concurrent users that we have to support, because the transport layer is the one which accepts the incoming connections, and it bridges the TCP layer to the application layer. So TCP layer has buffers, application layer has buffers. So the basically concurrency management is done through this transport layer. So now in Java, when it comes to Java, like Java previously has the IO package. Now it has introduced NIO package, non-blocking IO. So this non-blocking IO, the architecture of non-blocking IO is to handle hundred thousands of concurrent connections. The next part is to security integration, like how we can integrate the security into our software. So when it comes to like best practices, when you're developing a software, it is good to have like reusable components. So this modularization concept is very it's a good practice, because if we can reuse the code, we do not duplicate the code. That means if there is a bug, we only have to fix that bug in a one place of the code, because the code is not duplicated. And the correct logging is required to troubleshoot the issues, and overwhelm the issues, like the code base. Like in order to understand the code, the logging is required, and there should be a proper API documentation. And other thing is like the proper connection handling. Like we have seen there are, due to poor connection handling, there can be like some race conditions due to this poor connection handling. If we open an input stream or output stream to a file, we need to close that connection. Otherwise, file descriptors, too many connections, too many open files, like kind of errors will be thrown, and the OS level errors will be thrown if we poorly handle the connections, and it will affect the response time actually, because we need to cache the connections for a particular server. If we don't use caching, then it will, for the every request, the connection need to be open and closed. In that case, it will affect the response time. The observability management is another important aspect. So the observability is basically, we can say that observability as tracing, message logging, and monitoring. So those aspects needs to be considered. What kind of software that we use to monitor our services, how we trace the message in distributed setups, like when client issues a request, so this message is transferred to different services. So we need to identify what's the path that message is routed and how to backtrace that message. And it is important to keep data backups. Like when we deploying a software, we need to deploy it in a clustered, according to clustered architecture, where we have multiple data backups and data replication is supported. So I will go through some brief introduction of security and what kind of security is available and how we can integrate this security into software. Basically, there are hardware level security, network level security and application level security. So hardware level security is basically like we have separate devices for security, like cryptographic key storages, cryptographic processors. Those are dedicated processors, dedicated hardware to detect vulnerabilities in the network and in a computer, and do that in and mitigate those things in the hardware level. Next, it comes to the network level. In the network level, we have routers, switches, those kind of things. So in routers, we can use the like filtering, MAC address filtering, those kind of things, IP level filtering, and we can implement routing rules like access control policies. Those kind of things can be used in the network level. And firewalls, virtual private networks, those kind of things need to be integrated in going to the network security concepts. So in application security, basically the basic elements of this identity and access management of the of an application is based on user and users groups and their relationships and credentials. Credentials means like for a particular user, he has login credentials, username and password. If it comes to like when we're accessing a HPC, we have some SSH keys or that kind of, those are credentials. Though these credentials need to be stored securely. And entitlements is like how these users groups relations credentials are arranged together to form security policies for instance like group memberships, attributes, role-based access policies, attribute-based access policies. Those kind of things go to entitlements. And with these elements of identity and access management, there are some common integration patterns that we used in software development by integrating the security, the sharing capabilities. The sharing itself means like if I'm creating particular resource, then I can share it with my with some other person of a particular group. I can share it for a set of groups, that kind of things. So that's a basic integration pattern, how we can provide access to shared resources. The next thing is the synchronization. So when it comes to synchronization, let's assume like we have in Cyberwater project, let's assume that Cyberwater has their own user store. It is maintained for a long time and they have a large set of users. And now we're introducing the Apache iRouter middleware to this system, and itself, it has a user store itself. So synchronization of this iRouter based user store to the legacy user store is very important, managing identity and access for those users. So there are different standards that we can use for this synchronization, like scheme protocol, or there are different technologies. The next thing is like delegated identity management. So in iRouter, we are using delegated identity management. When user authenticated to the gateway, let's assume this gateway. So when user logs to the gateway, user based on his permissions, the middleware, this iRouter allows users to submit jobs to HPC clusters. So iRouter has the SSH key of this HPC cluster. So this middleware trusts this user by his own identity and delegates his identity, the resources identity, to submit jobs. In federated identity, what happens is like, let's assume that we are integrating we need to the user have a single identity, and he can use that identity across domains to identify things. Like, for example, we have institutional login in Cyberwater gateway, so that works on the federated identity because it user logs into the identity provider of their institution, but it allows gateway, which is deployed in a separate domain, to logs into the system. That's the federated identity management. So this integration patterns basically developed on top of different standards. Right? These standards are used when security integration. So OAuth2 is such a standard that used to integrate the authentication and authentication flows. Like, because when user logs into the web portal, it communicates with the identity service through OAuth2 protocol. The OAuth2 protocol itself developed based on grant types, client types, and scopes kind of things. So basically, grant type is there are different auth flows, authorization code flows, credential, resource owner password, that kind of grant types are there. They have different authorization flows. The basic reason to introduce this kind of auth flows is to standardize this, because there are heterogeneous clients. These clients need a common specific way of accessing these authorization servers. So OpenID is basically used for federated identity. So like, for example, let's assume that we are in gateway institutional login. Basically, institutional login is provided through a service called CI logon. The CI logon is a particular identity provider. So this identity provider need to talk to institutional IDP. That is a different IDP, identity provider, and the CI logon has a collection of IDPs. So the communication between CI logon and IDP happens through OpenID protocol. It is basically used for federated identity management. The next thing is OIDC. It is that's OpenID Connect, and it is an extension of OAuth2 standards. This OIDC Connect is basically used to communicate, basically used for authentication purposes, and it provides some claims, like we can obtain user attributes, user profile attributes like email, first name, last name, once the user is authenticated with the IDP. And there are some SAML and SACML, those kind of things are these authentication message exchange formats, because these messages also need to be standardized. That's why the SAML and SACML message are introduced. But now the popular the way is like OIDC protocol based on JWT, like JSON Web Tokens. This JSON Web Tokens itself, it is a self contained. It contains all the information. That token contains all the information needed by the front-end clients when user authenticates. After user authenticates, it provides all the user profile information embedded and encrypted in that JWT tokens. So, any questions on this section? Okay, so I think the next part is like deployment automation. So once how we can do the automation of the deployment of the code, like we have So this is called continuous integration and continuous deployment architecture. So basically, software developers do the code changes. They develop their codes through their favorite IDEs, and then these IDEs can be connected with GitHub or what kind of source code management software service, and that service. So there are tools like Jenkins, Travis Build, Travis CI. There are a lot of build and release tools that can be integrated into this source code management repositories to pull the code and deploy it automatically. So the continuous integration means like it is the developers can code. I think in next presentation, this part will be cover like what are the best practices for branching strategies, what kind of things will be, what kind of practices that we can use for that one. So continuous integration simply means like the developers can code, developers can continuously commit their codes to the GitHub, and there's a build tool will pull those codes automatically and build and go through a build process to deploy those codes into different environments. Like so normally we have like in a proper software deployment process, we have development environment, separate development environment, staging environment, and production environment. So once the development environment, so code is when developer commits a code to the GitHub, the code is pulled to the build tool, build process, build tool, and it builds the code, and it will deploy to the development environment. Once the testing is done at the development, all the testings are passed in development environment, then that deployment artifact will be moved to staging environment. So there are also some test cycles need to be done, then it will move to production environment. So this deployment and moving these artifacts into different environments is the responsibility of this build tool actually. So Jenkins is such a development tool, that the build tool, build and release tool that we can use. Okay, so Jenkins has basically 3 types of installation options. You can directly install to a cloud infrastructures like Azure, AWS. They have different deployment options for that. And you can do a local server deployment. So it supports Linux, macOS, Windows, or you can like use the Docker installation. So this is very easy for testing kind of things, but okay, so let's first go through what what are the features that Jenkins provides. Basically, it provides the build job management. So job is basically when developer commits a change to the code repository, that change should be automatically pulled and need to be built and deployed into a specific environment. So that is a job basically. So that job can be managed through Jenkins, and you can define separate workflows for these jobs, right? So after this job, so let's assume we have downstream we have a particular Git repository, and there is a dependency to another Git repository. So once this repository is built, there are some other downstream repositories that need to be built. So that kind of use case can be modeled using Jenkins workflow support. So the other features like Jenkins is able to widely scan organization repositories. We can mention this is our organization, and this please scan all the repositories that we have and build the latest change repositories. The other thing is like multi-environment deployments. I think I have discussed that previously. And it can, so there are authorization mechanism, authentication and authorization inbuilt methods that provided through Jenkins, like we can manage users and their permissions. So these users can only see what Jenkins happens like. So DevOps, like let's consider in the company which has a DevOps team, and this DevOps team has the members of that DevOps team has different roles. Like, so there's a DevOps manager and there's some DevOps, there are different roles. So based on these roles, they can provide the access to features of the Jenkins. And so another thing is like secured resource serve access. That means like when Jenkins deployed this build build artifacts into the different environment, different clusters, different servers. Those servers requires that those servers has some authentication mechanisms. For that, Jenkins needs to be authenticated with those servers to communicate, to deploy those artifacts into those servers. So that can be managed in Jenkins itself. And the most important thing is like it has a plugin architecture where there are already deployed common plugins, set of plugins for the Jenkins. So these plugins, you can select what plugins that you want and you can install it on Jenkins. Or any developer who like to extend the Jenkins, then he can develop the customized plugin and plug that into the Jenkins. So because Jenkins is based on Java actually, written in Java, and it is open source. So anyone can go to the Jenkins code base and they can develop their own plugins and plug that into Jenkins deployment. So, okay, so I think I can run some Jenkins server. Let's see how it works. Yeah, I'm going to run the Jenkins server through Docker. So this command will basically, can you see my screen?
Yeah, I can see the screen.
Yeah, we can see it.
Yes.
Okay, so
you can increase the font size a little bit, maybe.
Yeah, it's pretty small.
For the old eyes, this is a little tough.
Okay, so it is.
You can make it a full screen, and yeah, that may help.
Okay,
so Isuru, right now you are starting the server, right?
Yeah.
Server, okay.
Yeah, I just need to copy this password. So I'm starting this Jenkins server on a Docker through Docker image. So this, so I have started it on port 8080 on the local host. Let me go to my browser. So now you can see at the first step, when in Jenkins installation, we can unlock the Jenkins through the password provided at the server startup. And so now it comes to customize Jenkins. So this is the phase where we can select plugins to install or install suggested plugins. So if we go to select plugins to install, we can see there are a lot of plugins available. And Gradle for build tools, there is and Gradle, MS Build, Node.js kind of things. And there are analysis and reporting plugins, HTML Publisher, JUnit, XUnit, those kind of things. And for the pipelines and continuous delivery, there are set of plugins available: source code management, Bitbucket, ClearCase, CVS, Git, GitHub, GitLab, all kind of things are there. And distributed, for the distributed fields like Mac, it has several kind of plugins that you can select. So I will go with the install suggested plugins. So it will install all the plugins that required.
You only need to do this once in every machine, right?
Yeah.
Okay.
So you are using some recommended plugins in this case at this point?
Yeah. These suggested plugins, that these are default plugins that need to be installed.
Yeah, so while it is installing, so there are other CI/CD software, right? I mean, you mentioned Travis CI and other things.
Yeah.
How are they radically different, or are they pretty much similar in deployment? I mean, in starting and configuration.
I think they are they have the similar functionalities. The basic so the main reason for a lot of for these build tools is because, like, if you get the Atlassian Bamboo build tool, they have their project, they have their Jira system, so it is supported, inherently supports their Jira system. Likewise, so in like in Bitbucket also, they have a separate build and release tool that is specific to their system. Likewise, so these are initiated with their projects actually. So this Jenkins also first primarily released for as a build and release tool for their internal project now, and it is a open source and it keeps evolving. So so first we need to create admin user here, like admin. So now we can see the admin user is logged to the Jenkins. So this is the Jenkins dashboard. So here you can see we can manage peoples, we can check build histories, we can manage Jenkins, and a lot of functions are there. If you go to manage Jenkins, there are a lot of options available, and there's the Jenkins command line as well. If anyone familiar with commands that Jenkins provides, you can easily use this command line. and it provides statistics, system logs, system information, those kind of things. So let me try some. By registering another user and providing some uh, authorization to that user. So for that, we can go to configure global security. Here we have options. So there's a security realm. So this realm has like different. We can provide different user stores. We can provide if we have a user store. If we already have a legacy user store based on LDAP, then we can connect that LDAP to this Jenkins to provide the authorizations for that user. So we can initiate the own Jenkins user database as well. So there are a lot of options, and authorization strategies are there, like anyone can do anything. So there is no authorization, or we can use the logged in users can do anything, this kind of thing. So we can check this metrics based security. So this is where we can customize the security for users. Like let me, okay, so add that admin user. It detects the admin user, and we are providing, I can provide overall administrator authorization for that. And it has API token, enable API token usage statistics, allow users to manually create legacy API tokens. That kind of different options are there. You can go through their documentation for this, and let me allow users to sign up, which will enable the create account button, and I can save it. So, and if I log out, we can create a, and now we can create another account for a, let's say, read-only user. Uh, username, okay, so now the read-only user is logged to the Jenkins system, but that you can see the dashboard have nothing. This is just because this user does not have any authorization. If we go to this Jenkins, it says read-only is missing the overall read permission. So now what I can do is I can log through admin user and go to manage Jenkins and configure global security. In matrix base, I can add this read-only user. Okay, so read-only user is there. Now I can provide the overall read permissions, and I can save. So if I log out and log as a read-only user, now it has some permission. It has some items in the Jenkins dashboard. So you can see what users are there, and you can see the build history, views, that kind of thing. So likewise, we can provide so we can configure DevOps team members to have different roles in Jenkins to get their work done. And I will log into admin. So here, I can create new jobs basically. So there are different jobs, different project types like pipeline, multi-configuration, GitHub organization. This is where you can scan the organization for repositories, multi-branch pipelines, sort of a lot of options are available. Now I will go through some Hello World project. This is a freestyle project. Okay, so this is how you can define jobs. This interface provides different configuration options that we can use. So this is general. We can provide some description there. This general description. General hello world. Likewise, and we can mention discard all builds. This is a GitHub project. We can tick that one. We can throttle builds, like throttling means like we can limit the number of builds per hour or that kind of thing. The source code management is provide Subversion, Git, and if you provide Git, you need to provide the GitHub repository and GitHub login credentials and the branch to fetch the codes, that kind of thing. In Subversion, we also have different same kind of uh, Subversion repository URLs kind of things, like and those none. So build triggers, we can mention whether trigger builds remotely. You can develop your own script to build trigger builds, or build periodically, build after other projects are built, or GitHub hook trigger for Git SCM4. So this GitHub hook trigger is used by many developers because when a developer commits has a new commit, the new trigger, the Jenkins build is triggered through a webhook. Or we can define Jenkins to poll the GitHub repositories. Instead of this is a polling mechanism, this is a push mechanism. And there are different environments, like we can build environment. We can define specific actions for this environment and build steps, like what are the commands that we need to execute to build the project, like invoke and invoke rattle, invoke top level maven targets, likewise. So we can execute shell command, like we can use echo kind of thing. And post build actions are there. So after successful completion, what will happen? Whether we need to send an email notification, do we need to delete workspace, or we need to build downstream repositories, or we need to publish test results to another server, kind of thing can be configured through this post build action command. So now if you go to, yeah, so we have a project, Hello World is there, but I can try to build it now. So you can see that it is building. Also, you can see that job is built, right? It prints the echo Hello World, and in the build history, that to project, to Jenkins dashboard, if we go to build history, we can have what we can see that there's one project is built. So if you go to that, so we can see that this project is built success 33 seconds ago. This kind of statistics available available there. So there are a lot of documentation which you need to. So the recommended approach is not to, if you are deploying this to a Docker container, you need to manage it very cleverly using some kind of Docker management software. So these are the functionalities, basic functionalities of Jenkins that I want to discuss today. So I think the next part is yeah. Yeah. So all this I have shown these things. So next is like testing strategies that that we use in Irawate software development. So basically we do manual testing. So once when developer uh, develops a software service or function, we need to develop the unit test. So there are some libraries like JUnit and things, and you need to develop the integration test. Integration test means like it simulates end-to-end scenario. So there are some software frameworks for Java to develop integration tests, uh, like JUnit, and there are TestNG kind of things. So after all these things are done and successfully completed, we need to do load and stress test on developed service. We need to handle concurrency test, how it behaves. Is there any memory leakage? Is there any race conditions? That kinds need to be captured. So for a further investigation whether the software is correctly worked, we can do profiling. For Java, we have Java Flight Recorder and JProfiler. These are some things that I have execute through Java Flight Recorder. So JProfiler. So this JProfiler, like you can see that there we can view the memory. We can check how CPU works, what are the threads, how the thread blocking is happens, database related metrics, those kind of things can be analyzed. So in here, in this picture, the right hand side, it provides the memory, how the memory is utilized. So if you see that the memory is so here it is constant. That means there are no issues. If you see that the used memory is monotonically increasing over the time, that means there's a problem with your software. Ultimately, it will end up with uh, out of memory kind of issues. So you need to trigger. So you need to monitor that this GC activity, this garbage collection is very important in software, because there's when GC activity is triggered, we need to check how the memory behaves. Like it needs to be clean up. If it is not cleaning up, that means there are some memory leakages in the software, which will uh, eventually the software will be failed. And we need to check how CPU load is working. In some CPU intensive tasks, there are if there are any spinning conditions in the software or race conditions, the CPU load seems to be that one particular CPU node is keep triggering to keep overwhelming, and it is working 100% and other CPUs are isolated. So this kind of things we need to monitor and fix in the software development. So when it comes to UI testing, there are a lot of softwares available. Like for browser-based testings, we can use Selenium WebDriver. So you can integrate Selenium and it will automatically click it automatically fill data to your browser and do the relevant actions. If you have Nightwatch is a Node.js-based end-to-end testing tool. Mocha is popular for React-based applications. Protector is used for Angular-based ones. Those kind of UI testing libraries are available, and you can use those. So I think that's the end of.
Yeah, that's really helpful. I used Travis before, but it doesn't have so many features. And I remember I have to write the text description by myself. This is really convenient.
Okay, thanks.
Yeah, thanks.
Yeah, thank you very much. I think that's a very helpful information, and yeah, thanks a lot. So any other questions or any discussions or what we so please go ahead.
So this, I think this is being recorded. I think it should be posted somewhere. Frankly, you can post it on the gateway and
you
send
mean
us the links when it is ready.
Oh, you mean the gateway website?
Yeah.
Okay. Yeah. I'm the administrator, so I can post the link.
You know, you have used the Wagtail content management, right? In it or not?
Which kind of management?
Okay, so you haven't used it then. That's okay. So I mean, Isuru can probably help you in posting this record onto the gateway and send everybody links so people can go back and refer to it if needed.
Yeah, sure.
And
yeah.
also, I mean, I'm planning to use this in, I mean, this is because this is a very important information for, software development. I may use this elsewhere in other projects also.
Right. That's yeah. I think that's very important that we post it so that people can review it later on, or other people in our Cyberwater team, they if they are interested in, they can also look at it.
Yeah, that's a great idea. Yeah, and please post it and send us the link. Thanks.
Yeah, no problem. I'll put the link in the Gateway website, and then that everyone knows. Thanks.
Mm-hmm. Yeah.
Right. So I think we have used out our scheduled time today, but I wanted to at least use a few minutes to go, to lay out what's our next plans. So Levi, so you are going to give, so basically my understanding is and the next Monday and the Tuesday, that those time are dedicated to you. And so can you give us brief outline what you are going to present on Monday and what you plan to present on Tuesday?
And the plan of what you planned today that is not finished, and then we can push.
Right. If you have something not finished, which you plan to do today, and so maybe we can also do it. I don't have any problem.
Oh, we can definitely finish the other three topics over the next couple of days. Are we doing them Monday and Tuesday, or Tuesday and Wednesday?
Monday, Tuesday. Is that right, Feng?
Yes, Monday and Tuesday from 9:30 to 11:30.
So 9:30 to 11:30. So it is scheduled 2 hours each. Just like
I'm just trying to make sure that I have work off when I come in. Definitely. I think I do. We should be fun.
And is it the same link for the or so we are going to send out a new link?
I'm going to send a new link.
Okay.
Because the time is different, so I cannot do it in one.
Okay.
Yeah, right. So I think for next Monday and Tuesday, Levi will have 4 hours in total to cover 3 topics, right? So Levi will talk about defining a branching strategy first, and then pull requests, and then coding standards, right? Right, Levi?
That is correct. Yeah.
Okay.
Thanks everybody. I need to leave. I have another call right now.
Sure.
Thank
Yeah,
you.
thank you.
Thanks so much.
Thank you very
Thanks.
much.
Yeah, thanks.
Thank you. You take
Yeah.
care.
One thing,
Bye.
but I guess Isura will leave, and so if somebody can pass this information, or you guys can have any thoughts. I thought that testing was very interesting, and so is there any standard in the software community where you know, he listed unit testing and other testing and the steps. And so are there more standard ways that you can share with us? What are the other tests? He showed the unit test, and I understand that. And I think for example, Daniel used that a lot. But then how about the other testing? What if there are any standards in the communities that we should learn and try to implement that in the development teams when they are testing their codes?
Okay, so I will share some documents.
Yeah, sure. Thanks.
Yeah. Okay. Bye.
Okay, bye. Yeah, so basically, I think after our three presentations, seminars, we are going to figure out what exactly the test procedures we are going to implement for our Cyberwater.
Yeah.
Right. We need so now is kind of like the
education.
brainstorming. You know, brainstorming. We come up with all the available techniques, standards, and then we will see which ones we can adopt quickly, and which one adapt to our Cyberwater more efficiently, and then we are going to how we are going to implement it in our project. So I think that's the after those three seminars. So please keep in mind that we are going to come up with that recommendation.
That is great. I think that's a great idea. And so after those three seminars, after Tuesday, I'd like to suggest every one of us, students and the PIs, all are actively think and this, and especially based on what portions of the work you have been involved in, and then give us suggestions, and then we can discuss that and then come out with a strategy like you all suggested. I think that is that will work, and that's great.
Thank you. And one thing I'm thinking about is because after like Levi talks about the other three topics next week, and then Levi has started working on Jenkins since last spring. So we are continuing in that direction. Yeah, because I think today's Isuru's presentation is very helpful, but it's quite high level. So there's a lot in Jenkins that we have to maybe explore and see how we are able to use like a minimal set of features that will be needed for this project.
Yeah,
and
that
so,
sounds good.
Yeah, so I'm hoping that Levi will help us like explore that path, and then like write out a tutorial like on his own, like the other topics he has worked on, and then that will provide us with a minimal set of features that we can implement in Cyberwater. And then continuing in that direction, like testing is a great problem, but unit testing, I'm sure like the developers are already implementing that. But other than that, like the integration testing at the functional at the system level, functional testing, those can be very hard research problems. So my idea is after Levi and I explore a little bit about Jenkins, get that part, like the process implemented in Cyberwater, then we're going to take a look at, and I might need to collaborate with Yao and Feng and Feng Guang on some of the testing problems. You cannot like test, like look at like the complete system, it will be too large, but we will look at like the major components. And then we will think about how to do functional testing at the system level, apply some of the rigorous methods. Yeah, so those are like research problems. We can also work with Ren, for instance. So I need more time to after we identify like a specific component we are interested in testing, yeah, that might be a major component of part of the system. And then we'll look at like some of the rigorous testing methods I'm familiar with, like statistical testing, like we can try combinatorial testing. So we can pick out the problem, and then we can look at how we can design some of the test cases, yeah, to do automated testing. Or we can come up with the smallest number of set of test cases to identify the most bugs. So that would be very interesting. So
yeah, that sounds great. And then
yeah.
One suggestion is that before we decide what test how we are going to implement that, it might be useful for us that if you or Levi or someone can give us also a brief presentation to lay out what are the ones that are out there and explain a little bit their strengths and the pros and cons, and so that we get all of us will be on the same page,
yeah.
And then we discuss what are the relevant ones to our Cyberwater and how then we implement that.
Yeah, thank you. So I think there are no specific like testing methods that you have to use. So there are
right.
Like,
we just use the ones that are relevant and effective.
Right. So currently, like I think most of the functional test cases, they're written heuristically. Yeah. So basically, the testers, they know how to test it out, how to break the software. That's basically largely based on heuristics. So the reason I'm interested in like this kind of research, it can be a collaborative research with like Yang's team, with maybe Xu's team, with their students. Levi could participate as well, and I can have some other great students here to participate down the road. But the reason why I brought that up is because I think it's a research problem, and it doesn't mean that like the methods we are using, that's the most or the best one or the only one. It's just that it's a kind of research that is interesting, that we're able to apply these methods to find out how we can test it better and more efficiently. So it's more like a research idea, and then we're going to explore in that direction after we figure out like how to apply like industry practices like Jenkins, using the minimum features that would be useful for us for this project. Yeah, so I just wanted to bring up that idea. This is what I plan to do after Levi and I explore Jenkins a little bit more.
Sure, sounds good.
Okay. Okay, thank you. Thank you.
Okay, any other things that we would like to discuss today?
I think I will just post the time for the Zoom, like the notification for the next meeting like this afternoon, so that everyone be notified.
Okay, thanks. Okay, so if so thank you all very much for the participation, and I think we have a great two presentations today, and we are going to continue it on next Monday. And if we don't have any more discussion today, so we can finish it today now. And thank you very much.
Sounds good.
Thank you.
Thank you all very much.
Thank you. You have a good day.
Thank
Bye.
you.
Thank you.
Thank you.
Bye.
Bye. Bye.